Hi and welcome back, class. I guess we are recording. Yes, we are recording. Yeah, so this is the new topic. Okay, not very new because I think you are very familiar with this name, alcohol. Yeah, it's you might be thinking whether this is the alcohol that we normally associate with parties and stuff. Yeah, it is that alcohol that we're going to discuss, but we're going to discuss the not the taste or everything anything about that about this alcohol, but rather we will be discussing about the chemical properties and the uh, chemical representation of these alcohols, because alcohol is actually another group of organic compounds similar to alkenes, and now we are coming up to another group which is alcohol. Easy, right? All right. So what we will learn in this is we will learn what alcohols are, and also similarly we will learn about the chemical and the physical properties. Okay. So without further delay, let's go to the work. All right. So these alcohols are organic compounds. As I said earlier, they are organic compounds which have carbon-carbon single bonds. So they don't have carbon-carbon double bonds. They don't have double bonds. Like in alkenes, they don't have double bonds, but similar to alkanes, they have single carbon-carbon bonds. The most unique feature of this is it has a OH bond. Okay, that's the bond that gives uh, its unique feature to be a alcohol. Okay, so this is the uh, general formula: CnH2nOH. See, this OH is very important. This OH is the one that gives the alcohol the alcoholic property. Okay, so this n is basically a random positive integer number. Okay, so if you put 3 there, if you put n to be 3, so you can get C3, H will be how much, 7, and then OH, right? So similarly you can do it from n varying from 1 to 6, and then you can get uh, all the necessary alcohols needed for your syllabus. Okay, and the other thing is the names of these alcohols, always you will see they end with this particular suffix which is nol. Okay, so for example, if you have one carbon, if n is 1, you will have one carbon, and this is the uh, representation for an alcohol with one carbon, which is called methanol. Okay, so this is when the n is 2 and that means there are two carbon, so it is called as ethanol. Why ethanol? Because I told you this earlier also. If there are two carbons, the prefix will be eth. Okay, so you can go on drawing these. Go on drawing this until six carbons, which is hexanol, right? And you can also practice drawing isomers for this, because you can get multiple isomers when you you want to draw like for stuff like butanol or pentanol. Yeah, you can definitely come up with different isomers, and it's a good revision for you as to know what isomers are, because I might include isomers in this uh, assignment that I give you. Right? You don't know. We do like I you don't know, because that's correct. So I know what I'm going to give, but you guys don't know what I'm going to give. Right? That's the whole point of this. There's a whole fun part for me. All right. So that's the basic thing. And then we'll go to the chemical properties. Okay, so we'll look into the reactions of alcohols, how these alcohols react. Okay, so basically it undergoes two chemical reactions. Okay, one is oxidation, the other one is reduction. So what is this oxidation? So this oxidation happens when now you will be wondering, how are we to oxidize this? How are we to oxidize this alcohol? How are we able to achieve? What do we do? Should we just supply oxygen and are we able to do it? But actually, no, you can't do it like that. You need an oxidizing agent for this. So in chemistry, we have in in school chemistry, we come across two, mainly two uh, oxidizing agents, which is potassium dichromate and potassium permanganate. So here they have shown you potassium dichromate. This is potassium dichromate. If you Google and see, you can see there is something called potassium permanganate also. Now this potassium dichromate is actually um, orange in color, whereas potassium permanganate is purple in color. Okay, so that is also, be mindful of that. So what happens is, when you react this ethanol with this potassium dichromate, forget about this ethanol, forget about this, just worry about this reaction. Okay, so when you react ethanol and this potassium dichromate, and we also have this sulfuric acid. Why do we have sulfuric acid? Because we want to speed up this reaction. So sulfuric acid acts as a catalyst. Okay, so we are oxidizing this and we are able to get ethanoic acid. Okay, that's the way we are doing this. So ethanoic acid is also this ethanoic acid is also another organic compound which we will be learning in the next video. Okay, so it can be anything. So if you react propanol with potassium dichromate, you are able to get propanoic acid. If you react methanol with potassium dichromate, you can get methanoic acid, butanoic acid, and so on like that. Okay, so corresponding alcohol will give you the corresponding acid. Okay, and the other thing that you need to keep in mind is, like if you do it in experimental way, how do you know that this reaction had taken is over? How do we know? The only way we know whether this reaction has concluded or not is, now I told you potassium dichromate is orange in color. So initially the solution, when you react these, so the solution will be orange in color. But at the end of the solution, at the end of the reaction, the solution will be green in color. So there is a color change from orange to green color. Okay, so the color change is orange to green. Okay, if you react this with potassium permanganate, which is purple in color, initially the color will be purple, but after the reaction has concluded, the purple color will become colorless. So purple color will change into colorless. Okay, be very mindful of that. Okay, and be very mindful why sulfuric acid is used in this reaction. That is oxidation. Then let's go for reduction. So when you reduce, okay, when you reduce alcohol, you need two reagents. One of the reagents is sulfuric acid, and the other one is you have to provide heat. Okay, so in this case, also sulfuric acid acts as a catalyst, and heat also we have to produce, because so what does it mean? That means this reaction does not happen very easily. We have to provide a lot of energy and lot of support we have to provide for this reaction to happen. So we are providing that support using sulfuric acid and heat. As a result, we are able to obtain an alkene and water. So in other words, this reduction reaction, we can also call it as dehydration reaction, because we are removing a water molecule. Okay, because we are removing a water molecule, this reduction reaction can also be called as dehydration reaction. So if anyone tells you about what is a dehydration reaction, give an example for a dehydration reaction, then you can definitely use this reduction of an alcohol to uh, show it as an example. Okay, so propanol will give you propene, ethanol will give you ethane. So on, you can do that. Butanol will give you butene, propanol will give pentanol will give you pentene. Okay, be very mindful of this water. Okay, that's a very important thing. That is a chemical reaction, and in the next videos we will look into more chemical reactions, because these alcohols are able to react with other organic compounds and produce different compounds, so that we will learn in the upcoming videos. Then let's move our attention into the physical properties. Physical properties, you will find that the melting point and the boiling points increase as the carbon number increases. So basically, pentanol will have a higher boiling point when compared to butanol, propanol, and ethanol, and even methanol. similar to the density. So density of say methanol will be lower than uh, ethanol. Ethanol will have a lower density than propanol. Propanol will have a lower density than butanol, and butanol will have a lower density than pentanol, and so on. Okay, and be mindful that all these alcohols are colorless and odorless. That means it does not possess any color, nor does it possess any smell. So to test whether it is an uh, alcohol, the best way you can do is actually you have to perform a chemical reaction. So this chemical reaction that you can confirm whether it's alcohol or not. Out of all the organic compounds, you can carry out that oxidation reaction, because when you do that oxidation reaction, you have a color change. Okay, so the color change will tell you something. So be mindful about all what we discussed about this. Okay, in this particular thing. And so that comes, so with that I think we come to the end of the video. Yeah, we come to the end of the uh, recording of this video. So what we learned is, we learned a new group of organic compounds, which is alcohols. We determined the chemical reaction related to it. We determined the physical properties of this, and also I specified certain important details of alcohols that you need to be mindful of. Okay, so go through this video over and over again and be very familiar with this, and you will find the upcoming assignments very easy if you understand all the concepts correctly. Okay, um, and as I told you again, it will be a good practice if you if you draw the isomers for the alcohol. So it's good for you to draw them, and it's a good practice, and you will be doing a good revision, self revision for yourself. Okay, so if you have any doubts, please contact me through WhatsApp and let me know if you have any doubts, if you didn't understand anything. Okay, so I will meet you in the next video with a new topic. All right, thank you.